Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed with the next subtopic in chapter 4, which is logarithmic functions. Let y is equivalent to fx, where fx is a logarithmic function with the base a. The logarithmic of x with the base a can rewrite as y is equivalent to log x with the base a. And from this log terms, we can rewrite in terms of exponent as x is equivalent to a power of y. So in the logarithmic function, the x term here, we call that one as an argument. So this x, we call it as argument. And the values of this argument must be always greater than 0. Therefore, the domain of any log function should be equivalent to open bracket 0 until infinity. Why? Because let's say if you have the function of log 1, so the values with any base, so for example we have log 1 with the base 2, so the answer is equivalent to 0. So we still define when the argument is 1. But if you have log with the base 2, so log with the any negative value, so let's say negative 1. So if you check using your calculator, it will be math error, meaning that the function will be undefined when your argument is negative number. So that's why in general the argument of log function, so this what we call as argument, the x term, so it must be always positive number. And the range is equivalent to the negative infinity until infinity. So the relationship between the function of log and the exponential function, it is actually they are inverse to each other. So let's say when we try to get the inverse of the log function, we will get the exponential function. When you try to get the inverse of the any exponential function, you will get the function in terms of log. So that's why on the previous subtopic we have learned that if you have any function, exponential function with the base a power of x, so we have the domain of any exponential function in general from negative infinity until infinity, and the range of exponential function is 0 until infinity. Why? Because in the exponential function, we have the horizontal asymptote on the line y is equivalent to 0. Therefore, since it is inverse to each other, domain of the function f will become range of the function of the inverse function, and the range of the function f will become domain of the inverse function. So let's look at to the example here. How can we rewrite the log function in terms of exponent? So for example here we have log x with the base 5, it is equivalent to 3. So if you try to change in terms of exponent, so you will get x is equivalent to 5 power of 3. And then the next one we have log m with the base 1.2 is equals to 3. Therefore, in terms of exponent, we can rewrite that m is equivalent to 1.2 power of 3. Then the next one, we have the log with the base e, or normally we will rewrite in terms of ln a. So ln is actually log with the base e. So ln a is equivalent to the log with the base e. So we always put the log with the base e as a ln. So for this case, we can rewrite this one as, in terms of exponent, a is equivalent to e power of b. And for the last one, when you try to rewrite in terms of exponent, so we can put this one in the bracket. Therefore, y is equivalent to 1 over 3 power of x plus 2. So our power or the exponent here is equivalent to the x plus 2, or we can also put the bracket 1 over 3 power of x plus 2.